Hello, this video is about machine learning second assignment titled Iris Species Classification using Supervised Learning, Unsupervised Learning and Clustering Technique. My name is Mihira Premadasa and my partner is Sachini Karnatilaka. From the beginning to the end of this assignment, we both contributed equally to every part from data analysis and algorithm implementation to result in interpretation and report writing. This project truly represents a collaborative effort where we work together on each detail to achieve our final results. If I first discuss about the background, machine learning has grown rapidly and is now widely applied across various fields from image recognition and natural learning processing to self-driving cars and medical diagnosis. These are powerful systems designed to learn from data, make predictions, or assist in decision making with minimal human intervention. Uh, for this assignment, we selected the well-known iris datasets. Our main goal was to explore and compare different learning paradigms, especially supervised, unsupervised, and reinforcement learning techniques to see how each can be applied to this dataset. Our problem statement and objectives are: the IRIS dataset is an ideal dataset for comparing machine learning algorithm because it relatively small, well structured, and widely used as a benchmark in machine learning and statistics. Our main objective for this assignment were to classify different iris flower species based on their unique features and to test the performance of different algorithms in doing so. We set out our achieve the following objectives. First one is predict flower species using supervised learning technique, especially linear regression and random forest. Second one is identify cluster in the dataset using unsupervised learning algorithms, namely k-means and hierarchical clustering. Test Third one is test Q learning and a reinforcement learning algorithm to demonstrate how an agent could learn optimal action even with simple dataset is iris. Our main with these objectives was to analyze effectiveness of each approach, understand their unique strengths and weaknesses, and see how they perform and apply to a single dataset. Our methodology, we provide an overview of the process and tools we used in the project. We conducted our analysis using the Python programming language, which provided us with powerful libraries for data handling and machine learning. Our main libraries we used Panda, NumPy, Scikit-learn, Matplotlib, and SciPy. Uh, we use Jupyter Notebook as our coding environment, which allowed us to write and execute code interactively, making it easier to analyze our data with and visualize our results. The iris dataset consists of 150 samples, each representing one of the three iris species, Setosa, versicolor, and virginica. Each sample has four features: sepal length, sepal width, petal width. These dataset commonly used for classifying tasks and is well suited for analyzing different machine learning approaches. In our pre-processing step, we began by loading the data into Pandas data frame to allow for a easy manipulation. We then perform some exploratory data analysis to understand the distribution of each feature and the relationship between them. Basic visualization like a histogram and pair plot help us spot any patterns and trends in the data. Finally, we split the data into training and testing set with 80% used for training our models and 20% reserved for testing. This split help ensure that models could be validated effectively on data that hadn't been seen during training. I will invite Sachin to explain about the rest of the assignment and thank you very much.
Thank you, Mihira. Now, let's go over the results we obtained from our analysis. Starting with the supervised learning techniques, we applied two supervised learning algorithms, linear regression and random forest. First, we use linear regression primarily as an exercise to observe its behavior. Even though it is not typically suited for classification tasks, uh, here we used petal length as the target variable and calculate the mean squared error, which came 0.1199. This value indicates that the regression model reasonably captures the relationship between petal length and other features. However, as expected, linear regression showed limitations in predicting categorical outcomes like flower species. Our model's R2 score was 0.9634, indicating a strong fit. But again, it is important to note that linear regression is better suited for continuous prediction rather than classification. Next, we applied random forest classifier, which is more suitable algorithm for classifying species based on their features. The random forest model achieved impressive result with an accuracy, precision, recall, and F1 score of 100% on our test data. This confirms that the random forest classifier was highly effective in correctly categorizing each species. These results highlight random forest capability to handle small data sets effectively while capturing complex relationships among all the features. Overall, random forest perform exceptionally well for our classification tasks. When it comes to unsupervised learning, we used k-means clustering, hierarchical clustering. We implemented k-means clustering. We specified three clusters, one for each iris species. After running the algorithm, we evaluate the clustering quality using the Sailor score, uh, which came to 0.5512. This moderate score suggests that the clusters identified by k-means were reasonably well defined but still had some overlap between species. Visually, the k-means clusters show distinct group, but with some samples close to the boundaries, indicating overlapping characteristics among certain iris species. Next, we applied hierarchical clustering, which provided a different approach by grouping data based on their feature similarities. The dendrogram here the dendrogram here illustrates the relationship among the samples, helping us visualize the clustering process. We identified three main clusters corresponding to each iris species. However, as with k-means, some samples didn't fit neatly into the clusters, which is common in biological data sets. Uh, this further highlights the presence of natural overlap among species. In the last part of our analysis, we implemented a Q-learning algorithm as an example of our reinforcement learning. Our goal here was to demonstrate Q-learning's process of learning optimal actions in simplified environment. Our Q-learning agent had three states corresponding to the three species and took actions based on the iris flower features. As it trained the Q table, recorded the learned values for each state action pair. This Q table represents the agent's learned knowledge on making classification decisions. While this example served as an introduction to reinforcement learning, we found that the IRIS dataset is too simple for effective Q-learning application. In practice, Q-learning shines in complex, dynamic environment that involve real-time decision making, like in robotics or gaming, AI. While this study provided valuable insight into each algorithm's strengths, we did encounter few limitations. One major limitation was the small size of the iris dataset, with only 150 samples. It can be difficult to capture more complex relationships. Additionally, the dataset only contained 4 features, which limited the depth of our analysis. Moreover, we saw that some algorithms like linear regression and Q-learning were not ideal for this dataset. Linear regression is not designed for classification tasks, and Q-learning requires more dynamic dataset to show its full potential. As for future work, we would recommend using larger dataset with more features, as they could enhance model performance. Applying advanced feature engineering could also help, especially for algorithms that depend on finding nuisance pattern. Uh, uh, To conclude, this project highlighted the versatility of machine learning in solving classification problems. We saw that random forest performed exceptionally well in classifying iron species, making it is the best suited model in our study. Unsupervised techniques, including k-means and hierarchical clustering, provided a deeper look into the structure of the dataset. Though some overlap was observed due to the biological similarities among species, Q-learning introduced us to reinforcement learning, opening avenues for more dynamic tasks in the future. Ultimately, this project demonstrates the importance of choosing the right algorithm for specific tasks, as well as the need for thorough model evaluation. Thank you for watching our video. We hope this presentation has given you a clear understanding of how machine learning models can be applied across various paradigms and how they can offer valuable insights even with a small data set. In closing, we want to highlight that each part of this project was a joint effort. We worked together on every analysis, implementation, and result you saw in this presentation. This collaboration allowed us to fully explore each machine learning technique and learn from the process together. Thank you for watching.